Hello children, welcome to math part, the third part of exercise 22 we are going to solve today. So we start with the question number 21 now here. First 20 questions are done. There are 30 questions. So after going through the video, if you like it, please share with your friends. And if you are new to the channel, please subscribe. Start with question number 21. So you are given Q tan A is equal to P. Find the value of P sin A minus Q cos A upon P sin A plus Q cos A. Since Q tan A is equal to P, you get tan A is equal to P upon Q. So let us draw a right triangle where A is an acute angle. So A is an acute angle. Let this be B and C, the two vertices. Now tan is opposite by adjacent. So this is P and this is Q. Let us find AB by Pythagoras theorem. So you get AB is equal to square root of P square plus Q square. So we got this as root of P square plus Q square. Now let us find sine A and cos A. So sine A is equal to opposite upon hypotenuse, that is P upon root P square plus Q square. And cos A is adjacent upon hypotenuse. So you have cos A is equal to Q upon square root of P square plus Q square. Let us put the values in the equation which we have to simplify. P sin A. So P and sin A is P upon root of P square plus Q square into minus Q cos A. So it is Q upon root of P square plus Q square. Denominator is P sin A again. So P into P upon root of P square plus Q square minus Q cos A, that is Q into Q upon square root of P square plus Q square. So P times P is P square upon square root of P square plus Q square minus Q times Q is Q square upon square root of P square plus Q square. Denominator we have P square upon root of P square plus Q square minus Q square, sorry, plus, denominator is plus. So plus Q square upon square root of P square plus Q square. Take LCM, the denominator is same, we have root of P square plus Q square. Numerator we have P square minus Q square. Denominator again we have P square plus Q square upon square root of P square plus Q square. This P square plus root of P square plus Q square got cancelled. And our final answer is P square minus Q square upon P square plus Q square. We are done with question number 21. Question number 22. If sin A is equal to cos A, find the value of 2 tan A minus 2 sec square A. Now sin A is equal to cos A. So what we understand here, sin A upon cos A. If I take sin A upon cos A, which is equal to 1. And that is nothing but tan A. So we got tan A is equal to 1. So if I draw a right triangle with A as an acute angle, so tan is opposite by adjacent. So by Pythagoras theorem, we get this as root 2. We got this as root 2. So now let us find sec A. So your sec A is equal to hypotenuse upon adjacent. So root 2 upon 1, which is root 2. Let us put the values in this equation, which is to be simplified. So 2 tan A is 1. So 1 square, 2 tan square A minus 2 sec square A. Sec square is root 2 and then the square of that plus 5. 1 square is 1, so this becomes 2. Root 2 square is 2. 2 times 2, this is 4 plus 5. So which is 2 minus 4 is minus 2. Minus 2 plus 5 is 3. And we are done with question number 22. In rectangle ABCD, the diagonal BD is 26. So this is our rectangle. This is our rectangle ABCD where diagonal BD is given as 26 centimeter. And you are given cot of angle ABD, that is cot. So this angle we are considering, cot of angle ABD is equal to 1.5, which is 15 by 10, 5 3s and 5 2s are. So cot is adjacent upon opposite. So this becomes 3x. And this is your 2x. So cot is adjacent upon opposite. This is 3x and 2x. Now we are asked to find the area and perimeter of a rectangle. For that, we need to know sides. So by Pythagoras theorem, if I see here, BD is a diagonal. This is a right angle triangle. So we get 3x square plus 2x square is equal to 26 square. So 3x square, that is 9x square plus 4x square is equal to 26 square. So we get 13x square is equal to 26 into 26. So we get x square is equal to 26 into 26 upon 13. 13 2s are 26 times 2 is 52. So we get x is equal to square root of 52, which can be written as 13 times 4, which is 2 root 13 is the value of x. Now you are asked to find the area. So we have area of this triangle. Area is equal to AB into AD, that is length into breadth, where AB is 3x, that is 3 times 2 root 13, and AD is 2x, that is 2 times 2 root 13. So 3 times 2 is 6, 6 2s are 12, 12 2s are 24. So this is 24 and root 3 into root 3 is 13. So 24 into 13, we get this as area is 312 square centimeter. Now let us find perimeter. So perimeter of a rectangle is equal to twice length plus breadth. So twice length plus breadth. So length is 2 2s are 4. So it is 4 root 13 because it is 2 in bracket 4 root 13 plus 3 times you're having 2 2s are, you have 4 root 13 plus the width is 3 times 2 root 13, so it is 6 root 13. So it is 2 times 4 root 13 plus 6 root 13 is 10 root 13, which is 2 times 10 root 13 is 20 root 13 centimeter is the perimeter of the given rectangle. Got it? Question number 20. If 2 sine x is equal to root 3, 4, you have to find 4 sine cube x minus 3 sine x, 3 cos x minus 4 cos cube x. Now 2 sine x is equal to root 3. That means you get sine x is equal to root 3 by 2. So if sine x is equal to root 3 by 2, let us draw an acute triangle, right angle where x is an acute angle. And let us put the value. You have sine x is equal to root 3 by 2. Sine is opposite, so root 3 and this is 2. Let us find BC. So you get BC is equal to square root of 2 square minus root 3 square, which is 4 minus 3, that is root 1, which is 1 unit. This is 1. So you have now cos x is equal to 1 upon 2 and sine x is already, we have root 3 by 2. So let us find the first part of this. So which is 4 sine cube x. So 4 into root 3 by 2 and then the square of that, cube of that, minus 3 sine x, 3 times root 3 by 2 upon which is root 3 cube is 3 root 3, root 3 into root 3 into root 3 thrice. So this becomes 4 into 3 root 3 upon 2 cube is 8 minus 3 root 3 upon 2. 4 ones are and 4 twos are. So root 3 by 2 minus root 3 by 2, we get this as 0. So first part, we got the answer as 0. Let us start with the second part, 3 cos x. So cos x is 1 by 2 minus 4 cos cube x. That is 1 upon 2 cube. So which is 3 by 2 minus 4 upon 8. 2 cube is 8. 4 ones are, 4 twos are. So this is 3 minus 3 by 2 minus 1 by 2, that is 2 by 2, which is equal to 1. So we are done with question number 24. Question number 25, if sin A is equal to root 3 by 2 and cos B is equal to root 3 by 2, find the value of tan A and tan B upon 1 plus tan A tan B. Now sin A is root 3 by 2. So let us take an acute angle again, A as an acute angle, and this is B is another acute angle. So we have sine A is root 3 by 2, so opposite upon hypotenuse. So just now we have solved, we get this as 1 in the previous question by Pythagoras theorem. So we have now cos B is given to you. Tan A is sin A upon cos A. So tan A is opposite by adjacent, so which is root 3 upon 1, that is root 3. And tan B is equal to opposite is 1 and adjacent is root 3, so it is 1 upon root 3. So let us put the values in the given equation. So tan A, which is root 3, minus tan B, which is 1 upon root 3, upon 1 plus tan A tan B, that is root 3 into 1 by root 3. So this denominator becomes 2. Let us take the LCM. Root 3 into 3, root 3 is 3, 3 minus 1 upon root 3 upon 2. So which is 3 minus 1 is 2, and this root 3 comes down, so this becomes 2 root 3, so which is 1 upon root 3. We can keep this as 1 upon root 3 or we can rationalize. So rationalizing factor is root 3 now. So this becomes root 3 by 3. Root 3 into root 3 is 3. So either we can keep this as an answer or this one as our final answer. Question number 26. Information given in the following figure to evaluate 10 upon sin x plus 6 upon sin y minus 6 cot y. Now this complete is given to us as 21. We are to find out this part. Let us name it as D. So let us find DC by Pythagoras theorem. So which is square root of 20 square minus 12 square. So 20 square is 400 minus 12 square is 144. So which we get it as 400 minus 144 is 256. And square root of 256 is 16. So we get this as 16. So 21 minus 16, this is your 5. And then AB is 13 by because 5, 12, 13 is a Pythagorean triplet, or you can calculate AB by using Pythagoras theorem again, which we get it as 13. Now we need to know the values of sin x, sin y and cot y. So let us find our sin x. So sin x is opposite upon hypotenuse, which is 5 upon 13. Then you need sin y. So sin y is again opposite by hypotenuse, which is opposite is 12. So 12 upon 20. 12 upon 20, 4 3s and 4 5s. So it is 3 by 5. And also we need cot y. So our cot y is adjacent upon opposite. Adjacent is 16 and opposite is 12. So 16 upon 12, which is 4 4s and 4 3s. Let us put the values in this given equation. So 10 divided by sin x. So I'll write upon, instead of writing upon, I'll write 10 divided by my sin x is 5 upon 13 plus 6 divided by sin y. So sin y is 3 by 5 and minus 6 cot y. So cot y is 4 upon 3. 3 1s and 3 2s. Let us simplify. 10 into this becomes 13 by 5 plus 6 into this becomes 5 by 3. 2 times 4 it is 8. 3 1s are 3 2s are 5 1s are 5 2s are 13 times 2 is 26. 2 times 5 is 10 minus 8. So this is 36 minus 8. 36 minus 28. This is how we are done with question number 26. Plus cos square A. So sec A is root 2. So root 2 upon 1. Let us draw a right triangle again with A as an acute angle. So ABC, where sec A is a hypotenuse upon adjacent. So this is root 2 and this is 1. So by Pythagoras theorem, we get BC as 1. So we have cot A is equal to 1 upon 1, which is 1. Again, we have tan A is equal to 1 upon 1, which is 1. Sin A is equal to opposite by hypotenuse, that is 1 upon root 2. Cos A is opposite adjacent by hypotenuse, that is 1 upon root 2. Let us put the values in this equation. So 3 cot square A, that is 1 square, plus 2 sin square A, that is 1 upon root 2 and then the square of that, upon tan square A, that is 1. Tan square A is 1 minus cos square A, that is 1 upon root 2 and then the square of that. So 3 times 1 square is 3 minus 2 into 1 upon this is plus 2 upon 1 upon 2 upon 1 minus 1 by 2. So this is 3 plus 1, 4 upon 1 by 2, which is this 2 moves over here. 8 is our final answer. If phi cos theta is equal to 3, evaluate cosec theta minus cot theta upon cosec theta plus cot theta. So you have cos theta is equal to 3 upon 5. Let us draw a right triangle with acute angle theta. So let us be ABC is our right triangle. So cos theta is adjacent upon hypotenuse. So this is 3x and this is 5x. So by Pythagoras theorem, we get this as 4x. Now we have cosec theta is equal to hypotenuse upon opposite. So 5 by 4. Then cot theta is opposite adjacent upon opposite, that is 3 by 4. Let us put the values here. Cosec theta is 5 by 4 minus cot theta is 3 by 4 divided by cosec theta is again 5 by 4 plus cot theta is 3 by 4. 5 minus 3, this is 2 upon 4 upon 5 plus 3 is 8 upon 4. This 4 got cancelled. 2 upon 8, which is equal to 1 by 4 is the final answer for question number 28. If cosec A plus sin A is equal to 5, 1 by 5, find the value of cosec square A plus sin square A. So we'll be squaring both sides over here. So we have cosec A plus sin A, the whole square is equal to 5 5s are 25 plus 1, 26 by 5, and then the square of that. A plus B, the whole square is A square, that is cosec square A plus B square, that is sin square A plus sin square A plus 2AB, that is 2 cosec A sin A is equal to 26 square is 676 upon 5 square is 25. Now cosec A into sin A is equal to 1. So we get cosec square A plus sin square A plus sin square A is equal to 676 upon 25 minus 2. So 2 upon 1. So we take LCM here, multiply by divide and 25. So 676 minus 25 2s are 50 upon 25, which is 626 upon 25. Let us write this as a mixed fraction. 25, 25s are 625 plus 1. So 25, 1 by 25 is the final answer. Last question of this exercise. So if phi cos theta is equal to 6 sin theta, evaluate tan theta, 12 sin theta minus 3 cos theta, 12 sin theta plus 3 cos theta. So phi cos theta, so let us take this phi here, let us bring this sin theta, cos theta over here and 6 over here. So we get 5 upon 6 is equal to sin theta upon cos theta. So sin theta upon cos theta is nothing but tan theta. So that is how we get tan theta is equal to 5 by 6. Now let us draw a right triangle with the value of tan theta. Theta is an acute angle. So tan theta is opposite by adjacent. So this is 5x, this is 6x. Let this be triangle ABC. Let us find AC by Pythagoras theorem. So AC is equal to square root of 5x square plus 6x square. So which is 5x square is 25x square plus 6x square is 36x square. That is 25 plus 6, 6 plus 5, 11, carry 1, 61. So this is root 61x is the value of AC. Now what is sine theta? Your sine theta is equal to, this is root 61x we got. So sine theta is opposite by hypotenuse. This we get 5 upon root 61. Cos theta is equal to adjacent upon hypotenuse, that is 6 upon root 61. Let us put the values over here. So 12 times sine theta, so 5 upon root 61. Minus 3 times cos theta, so 3 times 6 upon 61, root 61 upon 12 sine theta, again 12 times 5 upon root 61, minus 3 times, sorry, plus, denominator is plus 3 times root 6 upon root 61. So which we get as 5 12s are 60 minus 6 3s are 18 upon root 61. Denominator we get 60 plus 18 upon root 61. This root 61 got cancelled. 60 minus 18 is 42 and 60 plus 18 is 78. Both are divisible by 6. So we get 6 sevens are 42 and 6 13s are 78. So this is how we got this as 7 upon 13. So children, if you like the video, please share with your friends. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.